Hello all and welcome to this first video of our series on circular functions. It's chapter 6 from the textbook. As you can see, we're still a bit behind, but we're certainly catching up. So we'll keep pushing on. There's quite a lot in this chapter, as you can see. It's what is pi, definitions of sine, cos, and tan, graphing them with transformations, additions of ordinates you can see down there in 6H, so adding two different circular functions together, and then the usual sort of things, determining rules for graphs. So if you're given key information, figure out what the equation is, some general solutions, which is when we don't have a restricted domain, and then applications as always at the end. Let's get straight into it though. This video should hopefully be nice and short. Here's a unit circle. What's special? What makes it a unit circle? It's a circle centered at the origin and it has a radius of 1. That's where the unit word comes from. It has a radius of a single unit. It could be 1 meter, it could be 1 kilometer, it could be 1 mile, it could be 1 yard. It doesn't matter. It just has a radius of 1 unit. Now quickly, let's calculate the circumference of this unit circle. We know that the circumference is equal to 2 pi r. It is also equal to pi times diameter. It's exactly the same thing because the 2 times radius gives you your diameter. In this case, we get 2 pi times by 1, so the circumference is equal to 2 pi. Whatever units that radius was measured in. Now if we jump into our calculator, we want to figure out what that is. 2 pi enter 6.283. So we could say it's roughly equal to 6.283. Now, where does pi come from, and how is it going to relate to this thing that hopefully you looked at a bit last year, but measuring angles in radians? A lot of the time we're going to now start measuring angles in radians and not in degrees. Where does pi come from? Well, pi comes from this relationship here. Okay, C is equal to pi d. People figured out, some very smart people at the time, figured out if you take the diameter of any circle, doesn't matter what radius or circumference it was, but if you take the diameter of that circle and then try and wrap it around the outside, you're going to get one around to about there, another around to about there, another around to about there, and then a little bit more of it. It turns out you get 3.1412, whatever it goes, diameters is equal to the circumference. Doesn't matter how big or small the circle is, if you take the diameter of it and start trying to wrap it around, to go all the way around the circle will be 3.1412 diameters. Or they said, oh, this is a really special number, let's give this a name. They called it pi. So pi number of diameters will give you your circumference. That's the relationship they figured out. Now, we're more used to seeing in this 2 pi r formula, which is just going, well, instead of taking the diameter, let's take half of it, let's take the radius, so we're halving the diameter. We're just using the radius. How many of them are we going to get? Well, instead of pi times, because the radius is half the distance, we'll have double that. So take the radius, there'll be 2 pi amount of them to get round to be the circumference. Okay, and we just rewrite that as 2 pi r is equal to c. Another really great way to think of this is, if we take the radius and we start wrapping it round, 1 will get us to about there. We've drawn that initial one. 2 gets us to about there. 3 gets us to there, and we get a little bit more. So if we want to go round just half the circle, well, half the circle's circumference will equal to pi radiuses. Okay? Take the radius, go around pi times, and that will get us around to 180 degrees. And this relates into, well, how is a radian defined? A degree, okay, is splitting a circle into 360 parts. Okay? One part is, I should say, 300. That's good. I know. I want to get this trend going. Okay. If we split one circle into 360 parts, one part will equal 1 degree. That's how a degree is defined. Take a circle, split into 360 parts, we get 1 degree. How is a radian defined? Well, let's look at these green marks. Okay, that's one radius, that's one radius, that's one radius. This is 0.141 radius. Is that if we split, and again, it was technically done with diameters and going around a full circle, but we get the same effect by, if we split a circle at every radius going round, okay, that's what we call 1 radian. Whatever angle is swept out, that is the size of 1 radian. So now you actually have an idea, roughly how big is 1 radian? Well, it's probably 50 something. If we think about it, 180 divided by 3 point something, we could just go 180 divided by pi gives me 57 degrees. Okay, so you can actually now think physically, if you think of that idea, well, when I go around 180 degrees, I'm going around pi radiuses. We're taking a radius, that's what we started with, and we apply 1, we apply 1, we apply 1, we're left with a little bit over. That distance that's swept out by 1 radius, we call 1 radian. Makes a bit of sense when you think about it that way. So we end up with these things that we get pi radiuses around, and we get pi radians around. That also means that we get pi on 2 to go halfway. To go over here, we get 1.5 pi radians to get round, and if we kept going all the way around, that is 2 pi radians to get all the way around, or 2 pi radiuses. If we look at, so to be really clear, when I say radiuses is when I'm applying them to the outside and I'm sweeping out that path. While if we're talking about radians, that's the actual degrees that match up for that distance. 1 radius, 1 radian in degree, in angle. We start at this x-axis when we're measuring angles. Don't ask me why we don't start at, say, I guess true north for bearings and things like that, but we don't. We start here and we measure our angles going around anti-clockwise, and that's considered a positive angle. If we go around clockwise direction, we consider that a negative angle. So we always start at the x-axis and then we start sweeping out an angle from there. So to convert from degrees to radians is just times by pi divide by 180, and then it's the opposite to go from radians to degrees. Way to think about it is that a degrees number will be much larger than the equivalent radians number. So if you're forgetting which one to put on top, well, if I'm going from radians to degrees, my number needs to get bigger, so I need to times by 180. If I'm going from degrees to radians, my number needs to get smaller, so I'm going to be dividing by 180. That's a great way to remember that. So convert these following degrees to radians. So we get 45 times by pi on 180. Now 45 into 180 goes 4 times, so we get 1 by pi on 4, which we can just write as pi on 4. Now if you want to think of that as an actual number, let's go pi divided by 4 we get 0.78. So we're going to sweep out that angle of pi on 4 is sweeping out 0.78 of a radius. Okay, 125, same thing, 125 times by pi on 180. How many times does 125 go in? We could divide both of those by 45. Pretty sure, 125 divided by 45. No, that doesn't work. Let's just put it in our calculator. 25 divided by 180 simplifies. Let's go that. Not complex. I want standard. 25 on 36. 25 pi on 36. 380 times by pi on 180. Both of those can be divided by 10, so we get 38 pi on 18. Both of those can be divided by 2, so we get 19 on 8 pi. Negative 140 times by pi on 180. Both those can be divided by 10, so we get negative 14 pi on 18. Both can be divided by 2, so we get negative 7 pi on 9. That's it. We converted both of those. I'm going to leave you. This is pretty straightforward. To do these ones yourselves to speed up the video. When we're converting from radians to degrees, and generally radians is going to have a pi in it. It's not always the case. Sometimes they might be written without a pi, but generally when they are, then that's going to cancel out the pi. We get 180 on 6, so that is going to be 30 degrees. And you can apply that same idea all the way through those. Lastly, we can use our CAS to convert between them. Where did I just press one too many buttons? So to convert between degrees and radians is you want to put your calculator into the mode that you're converting into. So for example, I want to convert into radians. You can see on my calculator that it is in radian mode because I'm going to convert something into radians. So it's just a matter of, say if I want to convert 320 degrees into radians, I put it in as 320, and then in Math 1 there's the degree symbol. You need to tell it, okay, that's actually in degrees. Just hit enter and it's going to give it to you in radians because the calculator is always going to represent answers in radians. Same thing going back the other way. If I want to convert a radian to degrees, well, I want my calculator to display it as degrees, so I change it to degree mode, and I might have, say, 5 pi on 4 as my distance. Okay, or sorry, my radians. Now I need to tell it that that's in radians, so there's this little R here next to the degree symbol. 5 pi on 4 radians. I'm in degrees mode, so it's going to now represent that as degrees, and it turns out it's 225. So that's how you use your calculator to convert between them. I can't stress enough how helpful it will be to be able to think in these terms of 1 radian is the equivalent to arcing out 1 radius around the circle. So if I said, just roughly, how big, okay, is the sweep of maybe 3 pi on 4, you can think of that as that's the same as 3/4 of a pi, okay? And we know pi gets us round all the way over to 180 degrees. That's our sort of reference point. We know that line is going to be there. Okay, so if we know pi amount of radians is equivalent to 180 degrees, we can then work from there. So I've got 3/4 of a pi. Well, takes me around to there. That also means I have 3/4 of pi radiuses around as the sweep coming around here. Really will be really helpful to you, especially when we move to graphing sine, cos, and tan, understanding transformations, understanding how they're actually defined. That's it for now. If you have any questions, please feel free to ask in class, put a comment in the video before, or email as well, or put something in Google Classroom. See you all soon.